Welcome back, everyone. In the last video, we learned how to combine radicals that were the same, combine like terms. And I told you that sometimes they don't look the same. That's a little bit more difficult, but with our old friend prime factorization, I believe that we can make that happen. So let's go ahead and do that. All right, so let's start out with a fairly simple example. Let's go ahead and do -7 square roots of 84 minus 4 square roots of 21. Now, obviously, 84 and 21 aren't the same thing. So the square root of 84 and the square root of 21 are not the same. I cannot combine those in their present state. So then the question becomes, can I somehow break this square root of 84 down into something that is the square root of 21? Well, there are shortcuts to do that. And if you're really good factors and perfect squares and all that, you can kind of see that. But I know one thing that works all the time, and that is our old friend prime factorization. So I go ahead and break this down into 2 times 42. That breaks down into 2 times 21. Now, I could continue going and break that all the way down and end up multiplying it back together to get that 21, but I can stop here because I found what I wanted. I got it all the way down to 21. Now, sometimes you have to break it all the way down and it doesn't stop there and you have to go back and multiply it back. But this is all the farther that I have to go, or all the further that I have to go. So what this means is that now I can break the square root of 84 down into, well, we know what that is. That 2 comes out. That's a square root of 4. So that 2 comes out. So there it is right there, times 2. Remember, anything outside gets multiplied, anything inside gets multiplied. Okay, so all we're doing, multiplying on the outside, multiplying on the inside. So I'm going to go ahead and bring that -7 down. And then what's inside, what's left inside is that square root of 21, or the 21 is what's left inside. So there it is. All I did was break this square root of 84 down into 2 times the square root of 21. That's all that happened. And I used the prime factorization in order to do that. Now I can go ahead and do this. And of course, according to Gimdos, I need to multiply first. Well, -2 times 2 is -14. So that's going to end up being -14 square roots of 21 minus 4 square roots of 21. All right, now I have like terms that I can combine. Well, I don't know what it's going to end up being, but I know it's going to be square roots of 21 because that's what I'm combining. Now I'm looking at a -14 and a -4. Well, what is 4 to the left of -14 on a number line? That would be -18. So there we go. There's my answer. All right, let's look at another example. Let's say that we had, I don't know, -3. Ooh, my goodness. Try that again. -3 square roots of 54 minus 10 square roots of 6. Well, obviously the square root of 54 and the square root of 6 are not the same thing, but maybe the square root of 54 can be simplified down to something times the square root of 6. And we know how to do that, or at least how to find out. We're going to use our old friend, prime factorization. So that 54 breaks down into 2 times 27. 27 breaks down into 3 times 9, which breaks down into 3 times 3. All right. So I know that these are square roots, so I'm looking for groups of 2 of the same number. Well, there's 2 3s right there. Okay, so that 3 comes out. This 3 right here comes out. So we'll put it right there. And I know I'm going to be multiplying, so I'll put a big multiplication sign right there. And I'll look at this here in a moment. Well, actually, I'm going to go ahead and look at it now. I'm trying to get this to be 6, right? Well, if that's left under the radical, isn't 2 times 3 6? So we got lucky there. All right, so we know that it's going to end up being 6 on the inside. Everything else stays the same. Yep, there's that bell again. All right, so the square root of 54 using prime factorization broke down into 3 times the square root of 6, which makes sense, right? Because the square root, or yeah, anyway, I'll break into that. Let's see here. So that's going to be -3. That's this -3 right here, times 3 square roots of 6, which is what square root of 54 breaks down into, minus our original 10 times square roots, geez, regular That's 10 times the square root of 6. All right. GIMDOS says that I have to multiply first. So negative 3 times 3 ends up being negative 9. So 9 square roots of 6 minus 10 square roots of 6. Again, I don't know what that's going to be, but I know it's going to be square roots of 6. So I've got negative 9 minus 10. Negative 9 minus 10. That's 10 to the left of negative 9 on the number line. So counting backwards, 10 backwards from negative 9 gets us all the way back to negative 19. And there you go. All right, if you have any questions, just let me know. Thank you.